This is a tutorial from my Introduction to Multiplayer Game Design class, where we are building a multiplayer virtual reality game using the Calisius.io system. If you want the latest information on what we're producing, make sure you hit the subscribe and the bell down below, and leave us a comment if you're interested in learning more about multiplayer game design, and make sure you check out our website, burtonsmedia.com, where we're writing great textbooks and resources on multiplayer game design, mobile application development, and other great resources.
So today we're going to talk a little bit more about the theory and some of the terminology that goes with multiplayer game design. We are using Unity 2020.2, though 2020.1 will work just fine. But as long as you're in 2020, you'll be good. Has anybody played with the different settings in 2020? Launching the HDRP versus the URP?
Not in 2020.
Not in 2020? It is night and day difference between 2019, especially if you go into HDRP. In my opinion, the out-of-the-box lighting in HDRP for 2020.2 is nearly Unreal level. So, it's not quite there. Unreal's got it down pat. But the lighting on HDRP looks fantastic. However, we need to take in consideration, what are we building this for? What's the end goal that we want to publish this to? Is it to a desktop or a console? Or is it to mobile or virtual reality? I want to build a tank game that is virtual reality. That is my goal. And since that is my goal, I'm going to be using URP, the Universal Rendering Pipeline, because it is specifically made for mobile or 2D graphics, which the Quest 2, Vive, Rift, all of those are basically based upon the Android operating system, have limited battery power, so they are a lot closer to mobile than they are to desktop or console. Console's got all these wonderful extra graphics cards to do the processing, and so HDRP works for that. HDRP is fantastic if you're doing a cinematic, but if we're going to create something that's our end goal is to either put it on mobile or to put it on virtual reality, URP is a much better way to go. So I'm going to go with URP for creating my projects. Just let you know what the thought process is and why we're doing that. So let's talk a little bit by the term server. If I say, well, set up your server, what immediately comes to your mind? So a piece of hardware running in a closet someplace, probably with its own air conditioning unit. If I was to say server, or somebody was to say server to me, that's probably the first thing that would come to my mind is a dedicated box. It may not have a monitor. It may not even have a keyboard. Those can be attached if needed as we move from server to server. Usually it is a headless box. And by headless meaning no monitor, no keyboard, no mouse. So it's just a box that's there to run software. Well, if it's a box that's just there to run software, then by server, do we actually mean software?
No.
Actually, yes, because it's dedicated, specific, specialized software to handle. Now, if I say we're going to need to host some things on a server, what comes to mind? If I need to do some web hosting, what do you think you need to do?
Get a domain.
Get a domain, okay. But if I'm setting up the server for that domain, what do I need to do? Nobody in here's had networking or client server, okay.
Are you buying it from like a hosting service? Or
You could be, maybe. Well, I don't want to worry about the domain. That's a distractor. Don't go with domain. Okay, if I'm setting up a server, the first thing that I need is something to run that software on. Now, whether that software is in the cloud or a laptop or a physical old computer that I have sitting in the closet really doesn't make any difference. But I need to set up an operating system that is made for handling servers. We put Linux, right? Get Linux running on something, and then we set up, in the old days, we would say Apache. You throw Apache on it and it does your web hosting and it's wonderful. And Apache is still widely used for web hosting, especially more static type web pages or WordPress or something like that. But if I'm making a website or a server
Got lots of information.
that is very dynamic,
Yeah.
I'm probably going to be using Node.js. Anybody familiar with Node.js? A couple people. What is Node.js? It's a package of tools
Yeah, that you have.
that you put JavaScript code on.
Mhm.
The beautiful thing about Node.js, and it was created in about, I think, 2009, because people were going, Apache, it won't do the dynamic things that we need to do. So in 2009, I forget the guy that developed it, but a guy came up with an idea, hey, we need a better way of doing this. We're all shifting to JavaScript anyhow. We need a package to run on the server that takes care of things. Now, Node.js was a huge advancement in how we were delivering web pages. So Node.js came along and it said, hey, let's do all this JavaScript processing on the server and then deliver the web page to the client. So it offloaded the client processing to the server. The server took care of all the processing and only delivered to the client the part of the page that it needed to see. That's a huge improvement in security. It's so much better, especially compared to all the JavaScript running on the client's machine and talking back to the server. So huge, huge advancement just from being able to do that. That made such a huge difference to how we were doing things. So if I want to set up, if I want to go to Amazon Web Services and I want to set up a server for a game client or for a web page or anything like that, I can go to Amazon Web Services, go to Light Sale, which is like $3, $3.50 a month, and hit the button and it makes a server for me in like less than 3 minutes. I've got a Node.js server ready to go. And I can just put my JavaScript files on the server and it processes it and builds the page from that. Now, because of Node.js, we now have tons of JavaScript packages, such as jQuery, Ajax, React. That's why the demand for server or full stack web developers is still so huge, because they got to understand how to build it on the server to deliver to the client. And they've got to be able to handle all the different types of browsers. Node really changed everything. And now we have tons of all of these JavaScript packages that are really just tool sets for making our lives easier. And when you come down to it, that's what Calisius is, the tool that we're going to be using this semester. It is a tool set made to run on top of Node.js, using the Node.js package, so that we can do delivery of all that information from the server to the client. Now, it just so happens that our client is a game, and what's running on the server is the game environment. If I'm organizing a server, there's multiple different ways that I can organize server-based communications. Now, this is kind of networking 101. If you'd had the networking class, a lot of this would be very familiar to you. If you haven't had the networking class, that's okay. I'm going to cover the basics of what you need to know. First of all, the entry-level type of network communications is peer-to-peer communications. This is When I was a student 30 years ago, it's hard to believe in my mind that it was 30 years ago. Seems like a blink of the eye, but yes, 30 years ago, I was living in shared apartments. People used to live there. I know nobody lives there nowadays. They use it for storage, but we lived there and it was married housing. So I was in one set of an apartments. Now these apartments over there are kind of weird. Some of them are 2-story apartments. Some of them are 1-story apartments. The 2-story apartments, you come in on one side and you go up a flight of stairs and your bedrooms sit over the 1-story bedroom apartments. So I had an apartment that had a room that was over my best friend's apartment room. And when I was coming back to school when I came to ACU. I had taken a few years off. I was in charge of computer networking at Ball State University, meaning I ran all the cables. I did the fiber optics. I did all of the DSL communications. I installed actually one of the first DSL communications in the country at Ball State University. Okay, so yeah, that's my background. I got bored with that and wanted something really challenging. Let's make games. That's really hard. I had a computer back then. We're talking 286s. These were, it was still early days in computing. I think the early 386s had just come out. It was like a 386 at 16 megahertz. Okay, I know, right? It's like, how could you do anything on that? We didn't have Windows back then. It didn't exist. But networking games had started coming out. And I think even like the very first World of Warcraft, it wasn't World of Warcraft, it was just Warcraft, Warcraft 1. And we wanted to play this game head to head. Well, I went out and got some cable, 4-wire strand cable, set up the serial ports, ran the cable out my sliding glass door, threw it over the roof to where he had his computer set up, and we plugged in to our serial ports and could play at 19 baud, 19K baud. That's slow. That's really, really slow. We played Warcraft 1 head to head. We networked in what's referred to as a peer-to-peer communications. Both of our computers acted as servers. Both of our computers acted as clients. That's peer-to-peer networking. It's not usually done for game design nowadays, but in those days, to have a network was unusual. There was no such thing as Wi-Fi. It was all hardwired cable, and usually your networks were set up peer-to-peer. A client-server architecture network was incredibly expensive and very seldom done. So everything to begin with was peer-to-peer. And so if you went into an office area and there was one laser printer, because laser printers were like $2,000, we would set up peer-to-peer networks where all the computers you'd have a line run from this computer to this computer to this computer to this computer, and it would go around until it was daisy chained until it got to the laser printer. And so if I wanted to print something, the information would pass through all the computers until it got to the laser printer. Now I'm oversimplifying it terribly, but that's basically what happened for the network communications back in the 80s and the 90s. So 30 and 40 years ago, that's how we did network communications. Peer-to-peer networks was where it was at because computers were expensive. To set one up as a server, we're not made of money. This is a university. Right. To set $2,000 aside for a listen server that all it was going to do was send information to the printer, that's insane. Now it's a card that you put into the laser printer, right, and
The USB stick.
Yeah, it's a USB stick. It's not a big deal.
Whatever you want, yeah.
You know, 30 years will do that to technology. But peer-to-peer communications was widely used in gaming as well, because that was the only option. You know, it was basically early day LAN parties, except we were using serial ports for communications instead of USB ports or networking cards. And that's how we had to do things. Then stepping forward 10 years into the early 2000s, networking had dropped in price. Computers had dropped in price. And so while having a dedicated computer to act as the server, LAN parties were huge. The internet was still too slow. Everybody was still on dial-up, and 33K just doesn't do it if you're going to have a first-person shooter, right? It's like, shoot. Yep, missed me. It was just too slow to consider doing that. So we started shifting to listen servers. Listen servers is a server running on one of the players' computer, and it hosts the game. So whoever has the best computer amongst the group is also going to be the server. Now, occasionally you'd also have somebody that, you know, if you're lucky at a LAN party, somebody in there had an extra computer and you could set it up to be the server, which again, it could be a headless server. It didn't have to have a monitor. It just needed to be there to listen, and then wouldn't have to have the client, and that would speed the operation up. But basically, the game server was the game running, and it didn't have to, if it was running on the same system that you were playing your game on, then you actually had two versions of the game running. One was being the server, one was being the client. You might not see what's happening with the server. You know, 10, 15 years ago, my wife and I loved to play Age of Empires. Awesome game. It was set up to use a listen server, and we could play it at home, and one of us would launch the game as the server, and the other person could join it. Great local area network game. But moving into 2005 and later, everybody started shifting to server-based games. We started getting into the dedicated servers. A dedicated server handled all of this. And really what brought about the dedicated server whole environment was World of Warcraft. It was the first majorly successful network-enabled environment that you had to have a fast enough internet connection to be able to play.
Mom, get off the phone.
You did not do this. You did not do this on 33K. You really needed to have some kind of broadband, and so. But this was at the beginning of the era of DSL, and people had a megabyte of throughput. They maybe even 3 meg of communication speed. If you had
That
5,
was ridiculously expensive.
it was like $100 a month to do that. It was insane. And I got to attend a couple of lectures by Blizzard on how they configured their game servers. And they referred to them as shards. Yeah, they would configure their servers, and basically on every shard, they would basically build a rack system of network computers. And they would take those this configuration, and as part of that configuration, there'd be a login server, there would be an account server, there would be a gameplay server, and maybe multiple gameplay servers. And I'll get into why you would have multiple gameplay servers in just a moment. But they would have all of this basically put on a rack. They would enclose it in a box and ship it to wherever it was going to be located at, which that's why you have the regionally located servers. So you might have one in Dallas, and another in Chicago, and New York, and Virginia, and Washington, and LA, and then you've got it. Yeah, then you got an Australian server, and an Eastern European server, and a Western European server, and So you had all of these servers set up, and you would connect to the one that's closest to you, unless you had a friend someplace else, but then you were going to have what?
Super bad connection.
Lag. Yes, the lag was going to kill you. And the monsters, especially if you're doing any kind of PvP, it was just going to be
Just
nasty.
move closer to your friend.
Yeah, right. But it was cheaper. You would die less often. So as we started getting into the dedicated servers, we would get into non-authoritative servers and authoritative. Now, early days of server-based game design used a lot of non-authoritative server, meaning that if I moved my character, I would move it on the screen and send that new location to the server. I would fire at my person that I was aiming at, launch the spell, whatever, and my computer would tell me whether or not I hit them or not. And then it would pass it to the server. What's wrong with that?
If your system's better than theirs, or your connection's better, you're gonna win every time.
You can just,
A better system is going to give you a huge advantage,
you can just send to the server and tell them to hit every time. no matter
or
what.
you could hack the system and tell the server I hit every time, which is a little suspicious. I always got a headshot. So non-authoritative servers are generally bad for gameplay, whether we're doing a card game like Hearthstone, or playing poker, or we're doing World of Warcraft or Halo or Battlefield. It's not going to work because people cheat, or differences in computer systems can make such a huge difference. So authoritative servers are where it's at. Now, not all authoritative servers are made the same. We've got a low authoritative server, a middle or mid authoritative server, and a high authoritative server. Meaning, how authoritative are they? At the high end of authoritative servers, we have maybe Halo or Battlefield, where the server, you don't get to move without the server's permission. You don't get to do anything without the server's permission. You can say, I would like to fire in this general direction. Is that okay? That's what the client asks. And the server comes back and says, just a second, let me compute that. And it does a raycast from the direction that your character's facing for your weapon. So basically a laser pointer goes out from your client or the server and figures out, did you hit or not? Then it updates everybody as to that status. That's a high authoritative server. Now, a mid-level authoritative server, I might go ahead and move the client on the client side, because there's nothing worse than I hit W and have to wait half a second for the character to move forward. That breaks the realism of the game. So I move my character inside the game and pass that movement to the server. The server updates the information, sends that out to everybody else. Hey, Burton moved, and this is his new location. So it gives a little bit better immersive and response on the client side and passes that information out. Now, shooting might still be calculated on the server. It's like, I'm facing this way. Did I hit? That calculation should still be done on the server. Then we have a low authoritative server. This is usually going to be more card games because I'm not worried about movement. I'm going to keep a card deck on the server. This is what's in the player's hand, but that's kept on the server. That's not shared to other clients. It does all the calculations again on the server, so that the client doesn't have to do that. Generally, your dedicated server is going to be an authoritative server on your system. It's going to take care of these calculations for you, or actually, you're going to make those calculations for the client so that there's no cheating. so that because this person's got the newest NVIDIA 380 graphics card doesn't give them an advantage over the person that bought their graphics card 3 years ago that just simply can't compete. It balances, it makes the game more fair. Now, you're still going to have an advantage from that super high-end system. It's just going to be more responsive. But for a multiplayer game, this keeps it more fair, more real, and especially once you start getting into the whole esports type stuff. That authoritative server is critical for being able to handle all of that accurately. Most of the games that we're going to be making in here are going to be from 2 to 20 players. This, when you're doing a high authoritative server that's for a AAA game, they're talking about hundreds of players or thousands of players at the same time. And that really has a huge impact upon what we're going to be doing. Okay, so let's talk about a little bit of terminology. What's the state?
The game state?
The game state.
So it's like what's happening right now.
And according to who?
Sure.
The server. So when I say what's the game state, I'm not interested in the client. I'm interested in what does the server see happening? What's the environment that it sees? Did anybody play World of Warcraft? A couple of people? Okay. So World of Warcraft, what happens if I go into town in World of Warcraft?
It loads in a bunch of stuff.
It loads in a bunch of stuff and suddenly people start appearing all around me. Now, it's fairly seamless, especially more recently.
Yeah.
Back in the old days when it first came out, 2007, it was rough. Because suddenly you just had, basically your computer would kind of stop while the server sent all this chunks of information to your client. And then finally it would catch up and you would be good to go again. But if you ran into a city, suddenly you had people around you and they're all chatting in the chat system. Now, once I left the city, it would always notify me, you're now in this new chat group for the region that you're in. And every different game calls it differently. But basically, I left one room and went into another room. So just like our classroom here, our interaction is limited to this environment. Now, somebody walking in the door, as they get closer to the door, might start picking up on what the conversation is that's happening inside that room. Or they're starting to load the content of what's happening in the room. Isn't that a nice little analogy? So we've got walking into a room and we're loading the content in. The closer we get, that content starts coming in. Oh, I decided not to go in. Well, we can discard that content. But it was starting to download from the server so that there was a seamless transition or semi-seamless transition as we went from room to room. So if I'm out harvesting whatever in the game, I'm limited to just that environment's interaction. I don't see any of the chat that's happening in the city. I don't see some Yahoo jumping up and down repeatedly on a statue, like there's something special or something like that. None of that happens on my computer. It's not sent to my computer. And even some of the larger cities, if you go into World of Warcraft, you got different sections. You got the Dwarven section and you got the Elven section, and you can run around to all these different areas. And I'm only getting the people and their movements in that section, in that room. So what we've got 17 people in this room. Well, 17 people registered for this class. I know we got some people online and not here today, but that's how many people, all your movements, all your animations, all your interactivities are going to be shipped from the server to my client telling me what's happening. Now think about that. Depending on the complexity of your game, what information has to be passed from the client to that room. What's the first thing that I need to know?
Positions,
Position. So XYZ. So position. What else? What's the next thing that I need to know about a character?
rotation,
Their rotation. This sounds very familiar so far. Those that you've been using Unity or Unreal or any game engine. So we've got the rotation and its XYZ rotation locate information. What else? What does rotation give me?
Where they're facing.
The direction that they're facing
where they're aiming.
and where they're aiming. Yes, where they're aiming. So, because if I'm building a model, and let's say it's Battlefield, I build a model, they've got a gun. That gun has a static location. As a player, I don't get to change in small ways the crosshairs on that gun, do I? Or
Change your whole rotation.
Yeah, I can only change the rotation. So if I've got XYZ, I know exactly where they're pointing because what up, down, left, right, all that stuff, all the whole rotation is all encapsulated in this information. So can I do a raycast from that for where they're pointed?
Yeah.
Yes, I can. That makes life a lot easier, doesn't it? So much easier. Okay. What other kinds of information would I want to pass up from a game? And let's say this is either a first-person shooter or an RPG or something like that.
Health,
Health?
health value. So that could probably just be an integer.
Yeah, it would probably,
Or a float.
yeah, usually this is going to be an int. So we're going to have the health. Maybe we'll have, do we need to pass that? Well, do I need?
It would just be resources in general, like the health and ammo and the other type of
But
resources.
do I need to know what your information is on my client?
Yeah.
Oh, I thought you were asking what the server needs.
Oh, yeah, yes, the server the server should know. The server already should know what my current status on health is.
Well, I mean, because if you, like in World of Warcraft or whatever.
Yeah, if I did a healing spell or something like that,
You can see someone's health above their head.
Yes, you can.
So it's like, yeah.
Yeah.
can pass that.
and mana and stuff like that. So health, mana, or endurance, stamina, whatever,
Level.
what their level is. And again, a lot of this information is going to be already on the server encapsulated. I just need to know if there's a change in any of this.
Yeah.
So if I cast a healing spell,
It updates their health.
it updates the health. Yes.
Now, if they are, let's say, in the middle of an animation, would you send the whole animation?
That's
Or-
where I was going. Yes. Animations. What happens with animations? Yes.
Would just be on the client side.
Yes. How many animations are there? I know
Quite a few.
but I know as the programmer how many animations are available. It's not like I, as the player, get to upload a new animation. So let's say there's 100 different possible animations. Running, jumping, walking, firing, crouching,
All the different combinations.
all the different combinations of animations that have been built into it. What do I need to send from my client to the server
When you start a new one.
when I start a new
Because you
animation?
don't need to be like constantly. like,
And what do I
still
need to
reloading,
tell
still
them?
reloading.
How can I encapsulate that information?
Like how you tell the.
I have to pass all of this to the server in the most efficient method possible.
JSON data? Or is it
Press fine.
who presses a button?
That's going to be your most, we'll get to that.
How would you just load that quickly?
But for animations,
It's just the animation controller or?
just a number.
Oh, yeah.
Number one's a walk, or maybe number one's idle. Whatever the idle animation is for that character.
The combinations have their own. number.
They all have their own number, and so I send the current animation number.
If it changes.
And again, that can be an integer. So suddenly, now the nice thing is, the server really doesn't care what the animation is that's happening. Maybe we do care. Maybe if they're doing a run, we need to figure out, well, they're running, they're moving faster. This position is going to be changing more rapidly. We can do a prediction of where they're going to be. So a run animation could be very useful information on the server
Or like a jump,
or a jump.
because
They're changing.
Yeah.
I say that reminds me recently, as in like the last maybe week or two, people found a bug in the way that data loads in Overwatch where you can send what an animation code to the server while your character that the animation doesn't belong to.
Yes,
And it like warps the model so bad it makes them do the animation even though they're not supposed
Right.
to do the animation.
but if the server has that information, all I have to do it to all the clients. Caleb's doing a jump. Code number 7. 7 goes to the server. The server then sends out, hey, Caleb's jumping. It sends out 7. And so the client can then interpret 7. The server doesn't have to do that. The clients do that.
So what if, let's say you're walking into a town and people are being populated and a character is loading and you're mid-jump. Using with that, you'd load in animation 7 for jump or whatever. And since the client knows what 7 is, it would then do the jump, but they were mid-jump when you entered the town. So there would be. So
It depends on how the game engine handled a jump. If a jump actually changes your XYZ location and your Y changes because of it, then we're just simply giving that Y and, oh, they're in a jump animation, we change that. And so we can tell that they're already in a start of a jump because we know where the ground is.
So, okay, I guess my question then would be, so the animation doesn't actually contain movement, the animation just holds the position of the body?
It's both. It holds the position of the body and which animation. But as animators, those who had animation last semester, what happens when I make a jump animation? Because really it's just a crouch and they're just floating there until they come back down. Because we got the start to it and we got the finish to it. The middle part is the same. So we just change the Y and put them in the middle part.
Yeah.
And with animations, again, those who had animation last semester, we can blend the animations. And so we can blend it quickly and occasionally it'll mess up. It's not going to be perfect.
Yeah.
We've seen that going into those types of environments.
Key poses.
Yeah, somebody stuck in a T or something like that until the server gets everything updated. That's why usually for most town situations, there's a long drawbridge that you've got to run across. That's your transition time as it's loading in.
There's no loading screen, but there's a half a mile loading.
Yes, they built into the server time for everything to be updated to the client. And if it takes you, 10 seconds to run across there, in server time, that's forever. I should be able to download a lot of information, at least for the beginning area.
Yeah.
And then I only actually have to update what you're looking at.
Right.
So as we move into different streets and different environments, it's like, oh yeah, this character 27 is over here on a different street. We know they're there in the environment, but I only need to be passing the XY or keeping track of the XYZ because I'm not going to see them. So rooms are very critical. And this information that we're going to be passing back and forth is the key to doing mobile gaming. Well, to doing any kind of server-based gaming. In Calisius, this is referred to as the schema. The information that is being passed from the client to the server.
Like a schematic?
Yeah, it's the schema. It's the schematic of the environment. It's the plan, the information.
And so depending on how many players there are, there's that many, and then the server just.
Well, the server can collapse all this
Into one.
into a table and send all that information out.
Okay.
So, and there's ways of, again, we'll get into all the
And then
complexity of
the
that.
client's job to break all that up and understand.
Right. And that's the client's job. The client becomes less about,
It's reading.
it's
not
reading the data and interpreting that and putting all the graphic niceties to it.
Right.
That's what the client does. We're going to be focused on what the server's telling the client. Now, we're going to take care of the client as well, but as we're going through this class, it's going to be about 70% on the server, 30% on the client. So this is cool stuff. This is the fun stuff. If you don't think this is fun, you're in the wrong class. This is. So we're going to be using Node.js for our server, at least to begin with. Later on, we're going to switch over to Nginx because a lot of good reasons. We'll get into that later. It's actually a better server system. But Node.js will get us started. It'll take care of what we need to do. And it's a lot easier to install on your local system.